So let's locate the y centroid of the shaded area. So what I usually do is to put the rectangle uh, parallel to the axis which I'm working with. So previously on the other video, I was finding the x centroid. So I put my rectangle parallel to the x-axis. So here I was gonna do the same thing by putting my rectangle parallel to the y-axis, but here when I put it parallel to the y-axis, uh, something's not right because there's no area there at that point right there. As you can see, the area is only going through there. So this is not acceptable. So use I have to use the x-axis again. So I have to put my rectangle parallel to the x-axis. So I still have my values. So the distance of this rectangle, the length is x, and here we have dy. So let's write the equation for the area of that rectangle. So dA is equal to x multiplied by dy. Now I have to remove that x over there. I have to write it in terms of y. So we are given the equation for the graph. So we have y is equal to 1 over 4x squared. So what I have to do now is to make x the subject of the formula. So I'm going to multiply both sides by 4. So I have 4y is equal to x squared. I can take the square root from both sides, and then x is equal to square root of 4y. So now I have dA is equal to the square root of 4y dy. Now I have to find the center of that triangle in the x and in the y. But since I'm looking for the centroid in the y, I'm only going to focus on the center of that triangle in the y. So the center of that rectangle, that rectangle in the y is equal to y. So it is just y. So we have something like this. The distance from there to there, it is just equal to y. So that is that center. And we know what y is that this equation right here, which is equal to 1 over 4 x squared. Now let's find the centroid of the shaded area in the y. So we have the centroid is equal to the integral from 0 to 4, multiply that by, this is y centroid, multiply that by dA over the integral from 0 to 4, multiply that by dA. So this gives us 0 to 4, multiply that by 1 over 4 x squared, multiply that by dA, which is the square root of 4 y dy. divided that by the integral of the area, which is the square root of 4y dy. So notice that we have x over there, so that x must go. We must remove it, and we will substitute that x uh, with the square root of 4y. So now we have the integral from 0 to 4, 1 over 4 x, which is the square root of 4y. So that is squared, multiply that by the square root of 4y dy, and then divided by the integral of the area from 0 to 4, and you can just plug that into your calculator to save time, and you should get a value of 2.4 meters, and that is your final answer.